Hello friends, welcome back to Padhiye with Prachi. Today is lesson 2 of class 10th Maths CBSE NCERT and the chapter is Polynomials. So let's start. So let's begin with chapter 2 Polynomials. You would have learned this in previous classes as well, that polynomials are expression in a variable, right? So px is a polynomial in x, right? So examples could be anything: x square plus 3x plus 2, x plus 2, minus 2x square plus 3, x plus 1. So these are the examples of polynomial. What is the degree of polynomial, right? So it is the highest power of x in px. So for example, in this case, the highest power is 2, so the degree is 2. In this case, x plus 2, the highest power is 1, so the degree is 1. There are other examples like 1 by root x plus 1. This is not a polynomial, right? So these are some examples which are not polynomials. Now we'll go to the different types of polynomials and what are they called, right? So first is linear polynomial. Ax plus b, it is written in this form, ax plus b, where a and b are real numbers and a is not equal to 0. Because if a becomes 0, then this will go away and it will just be a constant number and not a polynomial, because as we know, polynomials are expressions in a variable. So ax plus b is a polynomial, linear polynomial, whose degree is 1 and a is not equal to 0 and is a real number. So real number could be anything. It could be, as we started in our previous class, it could be an integer, it could be a whole number but not 0, okay? Integer, right? It could be a natural number, whole number, rational number, whatever it is. So that's what linear polynomial is. Next example is, so in example, as I said earlier, could be 2x plus 3, right? So px equal to 2x plus 3 is a linear polynomial. Then moving on to the next, which is quadratic polynomial. Ax square plus bx plus c, where a, b, c are all real numbers and a is not equal to 0. As I told here as well, why if this becomes 0, then it will just be bx plus c, which is a linear polynomial and not a quadratic. So quadratic is where the degree is 2. Cubic is where the degree is 3. So an example, so how it's represented: ax cube plus bx square plus cx plus d, where a, b, c, d are real numbers and a is not equal to 0, right? So again, quadratics example could be, which I have stated here, something of along those lines: x square plus 3x plus 2 is a quadratic polynomial. Cubic polynomial could be x cube plus 2x square plus x plus 3, whatever, right? So these are the three types of, and there are more also, 4, 5, where the degree is 4, 5. Polynomial is basically an expression in a variable. Now coming to the next topic, so we learned degree. Now what is value of a polynomial? Value of a polynomial, value of px at x equal to k. What does it mean? That we are going to substitute k in place of x. Substituting x equal to k in px. So for example, here it will become ak plus b. This will become ak square plus bk plus c. And this will become ak cube plus bk square plus ck plus d. So this is what is value of a polynomial. We are going to understand what is the implication of this, like why are we just substituting x by k, right? So we'll understand. So this is just what we have done is, we've said this is, I have told you in terms of k, but actually k is not k, it's like a number, right? So it could be 2, k could be 2, k could be 3. So let's see an example. So px is equal to x square minus 3x minus 4. Now we want to find the value of the polynomial at px equal to minus 1. So basically we are substituting minus 1 in the place of x. So what will it be? It is 0. So essentially in this case it's coming as 0. So then what is minus 1? It is called as 0 of a polynomial. Basically 0 of this polynomial. So what is 0 of any polynomial, right? It could be a linear polynomial, quadratic polynomial, cubic polynomial, and so on. So it means that, what does it mean? It means this: 0 of a polynomial is, if 0 of a polynomial is k, then pk equal to 0. That's what we found here, right? So minus 1 is known as the 0 of this polynomial. So let's take an example. Px is equal to 2x plus 3. Here, if you want to say what is the 0 of the polynomial, then we will equate it to 0, the value of x at which the value of this polynomial becomes 0, right? That's 0 of polynomial. So it will be x equal to minus 3 by 2, right? So if we just look at linear terms, if for a generic one, px equal to ax plus b, so what is the value of this? What is the 0 of the polynomial? K will be minus b by a. So what do we see here? If you look at this polynomial, px equal to ax plus b, a is the coefficient of x, b is the constant number here. So k, the 0 of this polynomial, is the value at which the polynomial becomes 0, is equal to minus b by a. So we can see that the 0 of a linear polynomial is related to its coefficients. So this is what we found out here, and I think we've done this, and we as in you and I and all of us have done this in our previous class as well when we learned about linear polynomials. Now we are going to also see, does it hold true for, say, quadratic polynomial? Does it hold true for, say, cubic polynomial? So that's what we're going to figure out now. Look at the geometric meanings of 0 of a polynomial. Why is it so important to know what a 0 of a polynomial is? As I already said, 0 of a polynomial px is the value of x, say suppose k, at which pk becomes equal to 0. So we have learnt in our previous classes that a linear polynomial y equal to ax plus b, we can use it to plot on the geometric line, right? Geometric axis, x-axis and y-axis, ax plus b, and this is a straight line. So if we plot, for example, this polynomial, y is equal to x plus 3, so this is how it will come up. So we can just show you how I have come at this. So value of x is 0, y is 3, value of x 1, y is 4, and if I go in the negative direction, value of x minus 1, y is 2, minus 2, y is 1, minus 3, y is 0. Right? So this is how I have plotted this line. Now, what is the 0 of this polynomial? It is x plus 3 equal to 0, which is x equal to minus 3. Now, interestingly enough, have a look at the graph here. This is minus 3. When x is minus 3, it is 0 of a polynomial. What are we finding from here? That 0 of the polynomial of a is the point where it is intersecting the x-axis, right? So it is intersecting x-axis at that point. So this is the 0 of polynomial, and there is exactly one such number, right? We already learned if y is equal to ax plus b, 0 of polynomial is minus b by a. So this is one such point. So now let's do for the quadratic such representation, geometric representation for quadratic polynomial, and then we'll also do for cubic, and there will be some interesting things that we find out there. We'll get to know how many zeros of a polynomial can exist. I think you already have the answer, but we'll look at it through the geometric meaning, and then we'll proceed. Let's do that now. So moving on to the geometric meaning of polynomials for a quadratic polynomial. ax square plus bx plus c equal to 0, where a is not equal to 0. What will be the 0 of this polynomial essentially would be when we equate it to 0 and the value of x when this becomes 0. So as in case of linear polynomial, we saw that it was a straight line. In case of a quadratic polynomial, we find out that it's a parabola. How would we find out? By plotting it on the geometric axis, right? So when a is greater than 0, it's like this, and when a is less than 0, it's like this. It's known as a parabola, right? So now this is the example that we are considering. We know that these are the zeros, right? -2 and -1. How do we know? We equate this to 0 and we find out. That we'll also plot on the x and y axis. So so this is how it is. So we'll substitute the values here, starting from, let's start from here, 0, when x is 0, 0, 0, 2. When x is 1, 1 plus 3 plus 2, 6. 1 plus 3 plus 2, 5, 6, right? When x is -1, 1 minus 3 plus 2, 0. So this is a 0. When x is -2, again 0. So these are the zeros of the polynomials. Then x is -3, 2, -4, 6. If we plot it, it's somewhat like a parabola here. So we see that it hits 2 points. It intersects the x-axis at 2 points, which are the zeros. So what is the geometric? That's what we are doing, right? Geometric meaning or geometric representation of zeros of a polynomial. As you saw in y is equal to ax plus b, in y is equal to a squared plus bx plus c also, it is the point at which it hits x-axis, right? So it leads us to an interesting observation or an interesting theory, which is that it can be represented in 3 forms. And what are these 3 forms? It could be that these 3 forms could be that it is either hitting like this or it is hitting like this. These are the 2 points, right? It could also be that it is just hitting like this or like this. What is this example? X square, right? X square is the example. This is x square and this is minus x square, right? So it is hitting just 1 point, right? The 0 of this polynomial is hitting just 1 point. Or as this case we just saw, this is x square plus 3x plus 2, where it is hitting 2 points. Like obviously it's not here. So it was somewhere in x square plus 3x plus 2, it was here, right? So this is something else, some other example. Similarly, it could hit like this or it could hit like this. And the third scenario could be that it is not hitting it at all. It's not hitting it at all. So these are those polynomials which do not have a 0. So either they have 1 0 or they have 2 0 or they have no zeros, right? Which cannot be solved for x, right? Which cannot be solved for x. You can see those cases which cannot be solved for x, where this polynomial px equal to 0 does not happen, right? So those are these examples. So at most, what do we come to know from this? At most there can be 2 zeros for a polynomial of degree 2. Moving on to cubic polynomial. So as we have understood here, even in cubic polynomial, the maximum number of zeros can be 3. And at that point, it will hit 3 times the x-axis. So we are going to show it through an example now. We are looking at the zeros of a cubic polynomial. We have taken the example of y is equal to x cubed minus 4x. And this is how it is represented in the number line, right? So if you look at the number line, even with this number, right, if you just put it as 0, you can see x minus square, x square minus 4 equal to 0, x is equal to 0, x is equal to plus minus 2. These are the zeros of the polynomial. And when we put these numbers here, we can see that y is 0, right? Because obviously we are saying that this is equal to y, right? So again, it's hitting at 3 points. It is, the zeros of the polynomials are the points at which value of x at which they are intersecting the x-axis, right? We have also plotted the other numbers here. So we see, so for example, if you put minus 3 here, minus 27, plus 12, just minus 15. So it's starting from here, minus 2, it's hitting the x-axis, minus 1, plus 4, 3. So it's going like this. So it's like it's going like this and like this and like this. I'm not shown it very nicely. Obviously, this is not drawn to scale, right? So this is how it is going to come. So it's hitting at 3 points. Now let's take another example, right? Y is equal to x cube. At 0, it is 0. At 1, it is 1. At 2, it is 8. At 3, it is 27. And similarly, negative direction, it will be the same, right? So how it'll come as at 0, it is 0. It is quite obvious that there's only one 0 here. Quite obvious. So it will be like this. 1, it will be 1. 2, it will be like a steep one. A very steep number and a very steep number. So there's just one 0 here. Now let's take another example. So just previous example we saw was there were 3 zeros, right? Now the next example we are going to see is x cube minus x square. Here, if we do it from our own side also, we can see that is x. So there are 2 zeros here. That's what we can see. We can plot it. 0, 1, 0. When x is equal to 1, then y is equal to 0. If you want to put x is equal to 1 by 2, for example, right? 1 by 8 minus 1 by 4, 8, 2 minus 1 by 8, right? So it's somewhere here. This is that point. 1 by 2 minus 1 by 8, right? So that's why we have made it like this. Then, so this is x is equal to 1, 0. Now if we take x is equal to 2, which is 8 minus 4, which is 4. So it will go here. Then 3, 27 minus 9, which is 18. So it will be again kind of a steep line, right? And if we go in the other direction, minus 1. So it will be minus 1 minus 1 minus 2. So it will be here. So it will be here. Minus 1 minus 2. We put 2 minus 2, then minus 12. So it will be quite steep one. So it's just hitting at 2 points. So again, what we saw with cubic was that there could be 0, 1 or 2. 0 we have not yet seen. So we've seen 1, 2 and 3, right? The examples that we have seen so far. The scenario for which we are not able to solve. So the scenario for which we are not able to solve a cubic polynomial, by solve I mean we cannot put equal to, it doesn't become equal to 0. It has some value or the other, and therefore it doesn't hit the x-axis like ever. What does the text say? In general, given a polynomial px of degree n, the graph of y equal to px intersects the x-axis at most n points. Therefore, a polynomial px of degree n has at most n zeros. So let's look at these examples, right? So these are some examples of some polynomial representation on the graph. So here the number of zeros is 1 because at one point this polynomial intersect x-axis. So we are finding the number of zeros for each of these polynomials. So here it is 2, here it is 3, here it is 1, here it is 1, here it is 1, 2, 3 and 4. Now let's look at exercise 2.1. Here the number of zeros for each of the polynomials. Here we can see it doesn't intersect x-axis at all. So it is 0. Here it intersects as 1 point, so it's 1. Here it intersects 1, 2, 3, so 3. Here intersects at 2 points, so 2. This looks like a parabola, so this is a straight line, linear. This is a quadratic line. Here it intersects as 1, 2, 3 and 4. And here it intersects as 1, 2, 3, right? So this is the solution for exercise 2.1. Now we'll move on to the next part of the aspect of the chapter, which is relationship between zeros and coefficients of a polynomial.